Okay. Who believes in zero defects? Is that possible? At least one, a few. Okay, there's still some work to do here. Some colleague of mine some time ago said, Niels, I'm working with this team and they don't believe in zero defects. And in one of your tutorials, you can download all that stuff from internet, from my website. I found this story. In my experience, the zero defects attitude results in 50% less defects almost overnight. That's cheap. Yeah. So, who's a tester? Okay, who's not a tester? A few lonely. Okay, almost everybody is a tester. Do you deliver zero defect software? Of course not, because only one did. Oh, you believe it's possible, but okay. So, I'm sure the requirements specify how many bugs have to be delivered. As I said in the video, yeah, apparently the developers, they do their best to implement the requirements. They deliver defects. Therefore, apparently they're required. And of course, you as testers check that they delivered the required bugs. Don't you? Okay. So, how much time in your project is spent in injecting the defects, and how much time is spent in trying to find and fix them? Any idea? 100, 0, 50, 50? If I assume the number is about 50-50, do you agree? 50-50 plus or minus 30%? Yeah. This is, well, some time ago. A little bit before the Agile, but I've been Agile even years before this, before the name existed. Typical large company in my country, even together with the university, they came up with this picture as a software development process. You see it. First half injecting the defects, second half trying to find and fix them. Where we know that developers are not perfect, but you are not perfect either, are you? Who's perfect? Oh, just a few. Okay. You're almost all testers, almost all not perfect, therefore you don't find all the bugs, even if they would be there, right? Now the problem is, assume that you find half. Is that a good assumption? Okay. Assume you find half, and the customer shouldn't find any, right? Okay, if you find one, the customer will find one. That's the meaning of 50-50. You find half. Yeah? If you find two, the customer will find two. Yeah? So, if the customer shouldn't find any, you shouldn't find any, right? Then the question is, do you sometimes get repeated issues? First, you find something, and then later you find a similar thing. Do you? Often? Okay, first time it's the developer's fault. Second time it's the tester's fault. Because you didn't help the developers from now on to prevent ever to repeat the same error, right? So how much time in your project is spent in defect prevention? Any suggestion? 0? Be honest. Anybody more than 0? There's a lot of work to do. Better quality costs less. Yeah? If you don't put the defects in, like Crosby, one of the guys from Zero Defects, he said, the error that isn't made cannot be missed. Let's define first, what is a defect? Any suggestion? What's a defect? Some people call it a bug. You know, a bug is a creature that creeps in the code and you can't do anything about it. No, it's a defect. People make errors and create defects. What's the definition? One of the definitions. This is one of my definitions. The cause of a problem experienced by any of the stakeholders using our results. Is that acceptable as a definition? Because if the customer or any of the stakeholders, the customer through the stakeholders, users, etc., if they don't experience any problem with our product, there's no defect, right? So, now, you know that half of the software made and delivered is never touched by anybody, right? That means any so-called defects that you have been finding in that part of the software that nobody uses is not a defect by this definition. There's only one defect, that that piece of the software was made. Did you ever enter that as a defect? Now, what is zero defects? And fortunately, not everybody left when they heard about zero defects, so maybe you want to learn something. What is it? It's not that we turn a knob and suddenly we're perfect. Yeah? I call it an asymptote. You know what an asymptote is? It's a line mathematically that you never reach, but you try to get as near as possible. Yeah? And we call this, do you see anything of that? This curve, we call it the learning curve. In the beginning, if you don't know anything, you make many mistakes. And if you learn, you less and less and less and less. So we learn to prevent all the mistakes. Yeah? Now the problem is, if you're asymptote, if you're going near, if your goal is a certain acceptable level of defects, guess what happens? Yeah? They produce 13 errors per 1,000 lines of code. That's the industrial average. Well done, developer. Yeah, you did a good job. Do you think they try even better? Come on. So the only way ever to get near to zero defects is have zero as your target. Yeah. When Phil Crosby, he wrote a book, Quality is Free. 15 years later, he wrote another book, Quality is Still Free. My experience is quality costs less, I told you already. Yeah. When he introduced this concept in his company, errors dropped by 40% in a few weeks. I was in a company with a team, and there were a lot of bugs. There was a handheld terminal. Yeah, and they were adding features and adding features, and every time they added the feature, they very quickly went, before it crashed, to try to check that the feature worked. Yeah, but then it said crash, and then they had to wait a few minutes for starting up. Just like Bill Gates, it takes minutes before your computer works. Yeah, and then they tried again. Yeah. So I said, what's the point in adding features if you can't sell the stuff? Yeah, useless. So I said, get rid of everything, take out everything, just a very tiny little bit, and make that stable. So 2 weeks later, I came back, and I said, well, is it stable now? Because they were already adding more features. Well, they said, it's much stabler. I said, if it's much stabler, so instead of a few seconds, it took a few minutes to crash. I said, we still can't sell this. Well, what's the point in adding any feature? So there were just memory leaks. There wasn't even a reason to have dynamically allocatable memory. So why were there memory leaks in the first place? But okay, we couldn't change the architecture in a few weeks because we only got a few weeks to salvage the project, otherwise... So, well, they found a few more memory leaks, and then it was stable. And they didn't understand what was happening. It worked. It kept working. And now they could add some features. So, in that, very clearly, my experience was that just by the attitude, it took them 2 or 3 weeks to understand that I was dead serious about this. I said, I don't want to see bugs anymore. And guess what? They didn't make them anymore. Again, that is cheap. I hear a lot about this Agile stuff, yeah, about mindset. The mindset. I don't want to see bugs. You see? You have to listen to the story, yeah? Or maybe it's just, okay. So, now you don't have to believe this, but Bill did it, I did it. Shouldn't you try at least? Maybe it works. I didn't believe it before I did it. Come on, I'm not better than you. But it worked. So try it out. And Bill said, an acceptable quality level of non-zero means that the organization has settled for a level of incompetence. Isn't that a nice sentence? You settle for a level of incompetence. Causing a hassle other people have to live with. And I liked that. I'm not native English, so I had to learn the word hassle. It gives me some feeling what it is, something, yeah? But interestingly, when I used no hassle in a project, it was easier for the developers to understand what I meant than zero defects. Zero defects is so absolute. But don't cause a hassle to the users. That helped. Okay, that's him, already dead, like all the quality gurus. That's another book. Cost only 10 euros. Buy it, read it. Yeah. He had the absolutes of quality. Conformance to requirements. Obtained through prevention. The target is zero defects, and it's measured by the price of non-conformance. The price of conformance is developing and testing once. After that, everything is the cost of non-conformance. Yeah, repair, as if you can do that, and then testing again, etc. Okay. There's a much longer story there, but we have only 45 minutes. I'm only teasing you on this, and tomorrow, well, after this, but everybody wants to go to dinner, but tomorrow I'm sitting there and we can discuss. Now, what's the goal of our work? My universal requirement for a project or for our work. In Agile, I'm not supposed to use the word project, so I say the goal of our work. Delivering the right result at the right time, spending as little time as possible. Is that a good goal? I can make it shorter. Delivering quality on time. The right stuff at the right time. And that's what I do. I coach projects to deliver better result in less time. That's my business. A little bit longer, providing the customer with what he needs, which is usually not what he says. Recognize? At the time he needs it, which may be earlier or later than he says. To be satisfied, because then he wants to pay. And to be more successful than before. Because if he's not more successful than before he delivered, why would he pay? But customer is king, but we are not slaves. So constrained by what the customer can afford. I mean, what the customer wants, he cannot afford, right? So if we start doing that, we fail from the beginning. Yeah? And what we mutually, beneficially, and satisfactorily can deliver in a reasonable period of time. Is that a good definition of a good goal of our work? Every word very carefully chosen. Okay. It's good to have a goal. Do your project always have a very clear goal, what you're working towards? Who has? Okay, good answer. Who has not? Just to check the statistics. You're fooling me. And who has not? Who has? Still fooling me, but I'm not going to waste more time. Okay. So, is root cause analysis performed every time? Yeah, I was sitting next to a guy who said he was reviewing code. I said I wanted to see what he's doing. And then he found some not interesting things. but they called them bugs. So I went to the project manager and the architect. I said, what do you do if you find these bugs? Do you do root cause analysis on them? On all of them? We don't have time for that. Okay. Who is doing root cause analysis routinely? Who is not? Be honest. Okay, a little bit better statistics. But what's the root cause of a defect? And there is some confusion there. Some people call the root cause of a defect the cause in the software that's wrong. What is wrong in the software? I have hopefully a better definition. The cause is the error that caused the defect, the error in our product that causes the problem at the customer. What's the root cause? What caused us to make this error and create the defect? That's the root cause. Only way, if you go that way, you can find the root cause and try to prevent. Because without proper root cause analysis, we are doomed to repeat the same things. As you just told me, they keep repeating the same things. You know all these things. Why am I still have to tell these things? Okay, we are QA. Who's QA? I didn't ask testers. I said QA. Okay. I mean, I agree. Testers usually say I'm QA. So I take the liberty to say QA, use the word testing, and I mean QA. You say use the word QA and mean testing. So who cares? But what has to do with this? That's developers. Yeah? Well, what's the goal of QA in a development product? What's the goal? To prevent bugs? Can you? Oh, okay, thank you. So let's define what's the main customer. What's your customer? Do you know who your customer is? Who are you working for, apart from your salary direct? Who are you doing your work for? What's the value you create? I mean, testing is waste because they don't produce anything, but yeah. What's the goal of your work? Who you're working for? Who's waiting for you? The user? And the user. Deming also dead, but the basis of all quality, plan to check act, etc., you know. Quality comes not from testing, but from improvement of the development process. Testing does not improve quality, nor guarantee quality. It's too late. The quality, good or bad, is already in your product, in the product. You cannot test quality into a product. Right? Okay, who's the customer of QA?
You can publish errata. You can publish errata.
Errata, okay. I could. The developers, thank you. Who put the quality good or bad in? The developers. So, who's the main customer? And what do we have to deliver to this customer? Remember my goal, if you agree. What they need, the time they need it, to be satisfied. Are your customers, developers, satisfied with what you bring them? To be more successful than without it. Because if they're not more successful, what's your job? Waste. So, testers and QA, they are consultants to developers. Doesn't that sound nice? Are you? So, some examples. Examples how to move towards zero defects. We are not perfect, but the customer shouldn't find out. Right? So, do you ever see software developers doing design? Whatever that is. Once I asked that in a project and they said, yes, we have a user interface guy. No, I said the design of the structure of the software, how it should be. Yeah. And then do you review? Yes, and then we code, and we review the code, and then we test, and the testers don't find anything. That doesn't prove anything, but at least it's a good start. And sometimes I use this as a success factor. Yeah. If it is used by anybody, there should be no question, no issue. If there's a question, I mean, once the product is out, you're not there to handheld the computer. So if they have a question, they shouldn't. If there is an issue, it's a defect, shouldn't be there. So anybody remembers the clean room approach to software development? 1, 2. We're getting old, aren't we? 60s, 70s. Routinely, they produced tenfold less defect in less time. Why aren't we learning this? Why aren't we doing this? The clean room said, if we find a defect, it's not allowed to repair it. You throw away your code and you start all over again. If you do that, in 1 of 2 cycles, you get clean code. Yeah? Human behavior. Yeah? So if there is an issue, no band-aid, we start all over again. What's wrong with the design? And if you go to the developer and say, what's wrong with the design? They say, with what? So often we have to reconstruct the design from the code, don't we? Who does? Sometimes. Oh, you must be all testers and not QA. Ah. So, what happens if you ask, can I see the design log? How you organized your design, why you make the choices you made? And that's how I did that. At the top of a chapter it says, what do I have to achieve? You have questions, answers, checkings, whatever. And after some time you say, okay, this is how we're going to solve it. And then 2 weeks later you find out it was a nice idea, but didn't work out well. So you repeat part of this. Design, review, code, review, testers don't find anything. Okay, an example. I was at a guy in Ireland, and he learned about this design logging principle. And he liked it very much. And then, a few years later, I was there again at another company where he now was a QA guy. And he said, well, I have this team. And I asked, what's the goal of the stuff you're doing? And no answer. So he called me, Niels, can you give them some requirements workshop to find out what the goal is, what they're doing? Okay, at the end of the day, we had the goal of 1 sprint. It's not so easy, but at least we had something. And because the guys were so clever, after that I didn't have to come back because they got the drill. So, that evening, they had their monthly pub day. Do you have a pub day every month? Yeah, the whole team goes to the pub and has drinks and bites. Yeah. And just that day, they had their monthly pub day. It was a Thursday. And I was sitting there, drinking my wine, and then James came. James was the guy who invited me. And he said, this is Louise. Louise, this is Niels, who taught me design logging. Tell your story. And then he left. So Louise told me, well, we had only 7 days to deliver a result. And we were working hard, coding, testing, coding, testing, coding, testing. Recognize? Yeah. I found that picture ages ago on the internet. But that's wrong. Never, ever. Yeah. James told me, stop coding, go back to your design. Back to my design, I don't have time, we have only 7 days. But apparently he came into this company at the level that he could say, stop coding, go back to your design. So she did. We designed, found the problem, cleaned up the mess of the coding and testing, all the mess you create by trying, etc. And we're done in less than 7 days. Thank you. So I made a web page on my website and sent an email to James. James, can you check with Louise that this was a real, as it was, that I interpreted her story right? And he came back, he said, oh, it was even more interesting. He gave the design to 2 peers for review. And then when Louise heard that, Louise said, if they're going to review, I have to do it much better. He said, no, you did your best. Let's see what happens. So, people not trained in reviews find hardly anything, right, Dorothy? So, they found some minor issues. And then he said, now let's do a final review. Then a colleague came in, and based on his expertise, the whole design was completely redone. He said, if we implement this, we get into trouble. They were already in trouble, coding, testing, coding, testing. Actually, he said, it was even more interesting. There were 2 features they were going to deliver. One feature they did this way, and it simply worked. And the other feature, guess what happened? Yeah, full of defects. So after that, that was clear enough, because all these clever guys there, they said, this is how we're going to work from now on, because we want to do better results in less time. Now, there are many ways to represent the design, and if you get the design, can you see what's happening there? It's a picture I got from some document from a client. So I said, let's find out what's happening there. It's a nice picture, yeah, but can you see any flaws? Anybody sees the bug there? So this is the way how I do it. That doesn't mean that's better, but easier for me. And now you see the bug, because in this case, n is n plus 1. If n is not, if n is equal, so either this or that. And this never happens unless you check this before you check that. So it's going to be a bug, probably. Yeah. So many ways you can represent a design, how you're going to implement it, but only few ways are right. So that your peers can quickly review it without having to dig in deep what is meant here. Yeah, in one glance they must already see, oh, there's a weakness there. Another example of this kind was some air conditioning equipment, controller, and something on the wall, like in your hotel room. But in this case, I don't know why they didn't use the phone, but in this case, in the US, there was a company who said, we want to equip these things so that the installer, the electrician who installs the air conditioning unit in the hotel room, can tune the air conditioning to the proper parameters through these few buttons and the display. Can you do that? Now, the controllers were made in one country, and that display was made in Switzerland. And they hired a systems engineer to define the requirements of the communication between the two. And they produced 47 pages of document, one picture like this, and then 47 pages with pictures like that. Copy, paste, copy, paste. Probably a lot of inconsistencies. Yeah. So is that a useful design? I asked the guys in that country, and then in Switzerland, I asked, did you read it? Oh, nobody read beyond page 3. Because it was boring, almost not readable. So I took the liberty to condense the 47 pages in one page. state machine. If you switch on the power at the beginning, and what happens? You don't have to read the text, it's just a way to represent the design. Then I discussed that with the guys in one country, and then went to Switzerland. You go to Switzerland, you're the coach here, you're way too expensive. I said, well, nobody's running this project, and if in October we don't have it ready in the US, they lose the project. Okay, you may go to Switzerland. So I went to Switzerland, discussed with the guys there, we moved a few things, and then that was the basis. And then on the train back home, I thought, if we are going to implement that in our controller, what would be the, could be the consequence? So that's my flow diagram of translation from that state machine to how to do it. And I sent the whole stuff to that company. 1 year I didn't hear anything, but the product is on the market. So when another year later I came back, I said, what did you do with that stuff? We implemented it. It worked. So, what's better than reviewing code? Should know by now. Does anybody review software? Or are we only testing without reviewing code? Who's reviewing code? Okay, some people. Who's reviewing designs? Who has designs to review? So, what's better than reviewing code? Well, by now you should know my answer. Yeah. How can I review code? How do I know that the code does what it should do and not what it not should do, which is 80% of the work, and usually not specified, if you don't know what it's supposed to do? Because our eyesight is quite limited, is it not? How many lines of code can you see in one eyesight? And how much design can you see in one eyesight? Bit more? More structure? Did you ever watch over the shoulder of your coders? Yeah. They're sitting there in front of the monitor. And what do you see? Or do you see also other stuff? I always see code. Yeah. And you see them switching from screen to screen. From screen to screen. And why is that? Because of this limited view. And in their mind they have to collect this to get a larger picture of what's happening there. So I was thinking, what's happening here? We have this poor brain of the developer. Yeah. And then he looks at that, in order to have some model of what it's supposed to do, right? But it's in our mind, so it's fading all the time, so he has to refresh all the time to keep the model in his mind up to date. And then, so that's what's happening there. And then the other side has to think what to do with that to change what they have to change. Poor mind. How about taking that out of the mind, taking that out of the mind, then your whole mind is there to do the job you're supposed to do. So, well, somebody thought about assembler. I'm a very old guy. Thank you. Yeah. But that and that and that is the same. And based on this, sorry, there's no secretary in the room or a coder in the room. The secretary can do the coding, right? Okay. This one, still important, there's a few minutes only. I had this Scrum team and they were planning their sprint. And I said, when will we be successful at the end of the sprint? I said, stupid. A strange question. We're agile, we're delivering software. Don't you know? If we deliver working software, we are successful. I tried, a computer always runs software. Even if you don't put anything in, it runs zeros and ones. Whether it does what it should do is another story. So the users couldn't even care less about the software. All they need is improved performance, because what you deliver is helping them with something they already do. The only reason why they use your software that they can do it nicer, better, faster, whatever. So, here comes my suggestion. No questions, no issues. That's impossible. I mean, how is that possible? We give it to stakeholders, we show it to stakeholders, and they always have questions. I said, very simple. You are clever developers. Simple requirement. If they ask one question, if they find one issue, we failed. So then they were thinking, maybe halfway the sprint we invite somebody to check it out, to see what they find, how it works and how it doesn't work, so that we have the other week to refine. So I said, good start. In the end, they succeeded, accidentally. But I don't have time to explain that, so if you want to know the end of the story, you come tomorrow or tonight. I can show you. But who is doing demos at the end of the sprint? Therefore it's important to finish with this one. What do you do with the demo? You show it, the word demo, demonstration, so you show what, and you say, is this nice? Oh, looks like nice. Can't you change that color from green to yellow? Because that is boring, these demos. And if it's boring, they start asking boring questions. And then the developers write down, or the product owner, new requirement, they want yellow. Yeah. So, my suggestion is, give it to them, zip your mouth, handcuff your hands, and observe. You will learn so much more. And then you can talk business. Once you see what they did and what they didn't do and how they used and abused your result. Is that what you do in a demo? Maybe next time. So there is a little bit more. You can download it from our website, and probably also the video will be made. So I think that's about the end because of the time. Maybe this last one. There was one suggestion I gave to this project. What we deliver will be used by the appropriate users immediately within 1 week of not making them less efficient than before. Is that a good requirement for what we deliver every sprint? Yeah. Appropriate users, immediately they use it, because we need feedback. If they don't use it, we don't get feedback. Within 1 week, not making them less efficient. That's not a strong requirement, is it? If the delivery isn't used immediately, we analyze and close the gap so that it will start being used. Because we need feedback badly, right? The proof of the pudding is in the eating when it's eaten by them and they find it tasty. If they don't find it tasty, we failed. The users determine success and whether they want to pay. Yeah? Because if they're not happy, why would they pay? Okay, let's stop here. There are more examples, but the time is limited. Thank you.